Hi, so in this session of IoT today, we will study about the IoT enabling technologies. Now, we have studied about the IoT architecture here. So, we have studied there about the sensor connectivity layers. So, these sensor devices need to communicate in a personal area network or in a wide area network. So, that means we need a strong transmission technology. That means so that these uh, various smart devices can communicate with each other. So for that purpose, we need some technologies here so that the transmission is not interrupted. That is seamless. Now we have requirements here for personal area networks and for your wide area networks. So for that, we have some technologies which are enabling here standardized platform for your IoT. So we have technologies like your Zigbee, RFID, NFC, low Bluetooth energy, and IPv6 over low power personal area network. So these are some of the IoT enabling technologies, and beside that we have for like wide area networks. Uh, these here work in collaboration with your Wi-Fi and your Ethernet system, but some devices here directly connected to your wide area network. So for that purpose, we are using our cellular technologies like your GSM, LT, and the upcoming fifth generation technology. So we will study here these IoT enabling platforms. So today in this class, we're going to study about Zigbee. So Zigbee basically is an IEEE 802.15.4 specified standard for your personal area network. More specifically, I would say that wireless personal area network. That means this technology here enables to communicate the various devices in a wireless personal area network here. So using this Zigbee technology here for your Internet of Things. So this is a very standardized, or we can say that the most common and popular industry for your wireless personal area sensor networks, and it has also been called the Internet of Things. That means the various automation industries then and your wireless sensor networks, your WSNs, are utilizing this technology. So somehow it is also referred as the Internet of Things here. So that means we in the IoT systems here we have the Zigbee enabled devices which are they are used to communicate with each another. For example, in your smart home, your Zigbee enabled coffee maker can communicate with your Zigbee enabled toast maker. So that means for a complete smart infrastructure, for your smart homes, for your smart office automatics, this technology is being used here. Because in IoT, we require low power, low throughput, and low bandwidth. So this is the technology here which is meeting here these requirements. So your Zigbee here is a simple protocol based technology which utilizes low power, low data rates, and uses the digital radio for the transmission, or we can say that enables a simple communication between various wireless sensor nodes here. That means we will have several nodes which will be collecting the information from the real world, and then some of the more intelligent nodes here which will be routing and forwarding the information. So that means we have our sensor devices, then the information which is being collected from these devices here, the information is to be forwarded to some another application there. So we need here certain gateways. So that means if this sensor device here needs to send an information to certain gateway, you need a certain technology here. Like for your person area networks, you have this Zigbee technology here. So this is a wireless personal area network technique which provides the data rates up to your 250 kbps and a channel bandwidth of like 5 megahertz. And the most important characteristics of this technology is that it can support a number of nodes. If you just talk here about like your Wi-Fi, so it can support a limited number of nodes in a particular area. But this network here, Zigbee enabled network here, can support thousands of nodes at a time here. So now moving further, we will study here about the Zigbee devices and the Zigbee operating modes, and then how Zigbee works, the addressing, the physical and the MAC layer of your Zigbee systems, and how finally IoT is utilizing this technology here. So next, what we have here is the Zigbee devices and operating modes here. So first of all, for your Zigbee devices, it has two types, FFD and RFD, where your FFD refers to full function device, and this is your reduced function device. So we know there will be a number of devices here in the Zigbee network. So there will be some reduced function devices and full function devices. Now, if you talk here about the full function devices, so that means this is an intelligent device system, because this here contains especially the routing capabilities. That means it has either a personal area network coordinator, or we can say that the Zigbee coordinator here. So that means this device here act as a node also, which is communicating with the physical world and acting as a router also, coordinating the Zigbee network here. Now we have reduced function devices here. So these reduced function devices just acts as your simple nodes here. They just communicate with the parent node and they have no routing capabilities here. So in your Zigbee network, you will encounter these two types of devices here. Now, after the Zigbee devices, next we have the operating modes here. So this operating mode here is directly related to your devices here. Now you will have here ZC mode, for example. That is your Zigbee coordinator mode. So this mode is an intelligent mode because this is the we have a Zigbee coordinator here, or a personal area network coordinator here, which is considered as the root of the network here. Then they have the routers here, which has the capability of routing. So if you have now next above that, we have to check that how this technology actually works. So basically your Zigbee here is supporting, and how it works, it supports basically three kind of topologies here: star topology, mesh networking topology, or your tree cluster topology. here. So these topologies here will have these operating modes. It means, for example, your mesh networking is mostly used for your IoT. So in that particular operating mode, you will have a Zigbee coordinator, you will have simple nodes also, that is your reduced function devices and your full function devices also here. Now we're saying that Zigbee is creating a wireless personal area network in which number of sensor devices can communicate with each other. So that means Zigbee technology is working. It is using the digital radios here to communicate with each other. So that means, first of all, for the successful working of a Zigbee network here, that means Zigbee enabled, if you have Zigbee enabled devices in a smart home or a smart office, and it is using their, just take an example. So that means if this technology is being used, so it has Zigbee enabled devices here. So it is following your mesh network. Mesh topology is basically used because it reduces certain kind of redundancies here and self-healing capabilities also. Now, in that network, you will have a different number of nodes here. Now, suppose this is your Zigbee coordinator here. Then you will have these routers. That is your full function devices here. They're gathering the information also and storing and routing also. Then you can have these also, which basically refers to your simple nodes or your RFD, reduced function devices here. So these are the gateways here for your physical world. That means gathering information from the physical world and then transferring to your wide area network. So this is acting here as a gateway. Now that means for its working, what it is utilizing, it is using the radio, your digital radio. That means your low frequencies there to transmit this information. Now, the setting up of this part is important. That means your personal area network coordinator setup is very important here because this coordinator here manages all the nodes. It manages the information about these nodes and it also manages that what information is being transmitted by these nodes. So this is here important. Now, either working in this topology, either working in this topology. Now, how these various devices will be now encountered? That means how they will be differentiated or how they are identified there, because there will be hundreds of devices there in your network there. So for that purpose, what we have is we have the Zigbee addressing here. So that basically refers that any device which is a Zigbee enabled, that means it is IEEE 802.1.4 specified here. So that device from the manufacturer sites will have an OUL address. So this OUL address is basically here organizationally unique address here. So this is here your 64-bit address. So this is the first address which is encountered here with your Zigbee enabled sensor or your device. Now when a Zigbee device joins this network, it receives NWK address here. Your network address, which is your 16-bit address. Now, on the basis of these two addresses, a particular sensor device is identified here. So, the PAN coordinator here will be using any of these addresses so that the devices here are capable of sending the information from one node to another node. So, any of these here will be used for the communication purpose here. So, how it is working, that it is just collecting the information from a physical world. That means we're using the analog to digital converters there. We have certain ADC converters here for the processing of that data. Now after that, the device is either your OUL enabled and then it receives an NWK address when it joins the Zigbee network here. So this address is also your endpoint address. So this is the identification here, and then this is a scenario here for your Zigbee working. Now after that, we have the Zigbee specifications, that means the Zigbee protocol stack. Next, we have the Zigbee protocol stack here. Now, first of all, we know that we have the physical layer. Then your MAC layer, your network layer. Then you have your application layer here. So this is the application layer is basically also your customer or consumer applications here. So this application layer is basically consisting your application framework, your application profiles. So now here, if you have your physical layer, so like this is your silicon, and this is where your Zigbee works, and this is your application layer. So we will study here the physical layer and the MAC layer for your Zigbee technique. So in the protocol stack of your Zigbee, first of all, you have the physical layer here. Now, as we know that physical layer now of any system is here actually concerned with the actual transmission and reception of the data here. So it specifies the electrical specifications, the mechanical specifications, and the media through which your information is being transmitted here. So that means it then deals with the data transmission and reception, the modulation and demodulation techniques which we're using here, and the spreading technique which we're using here. So for Zigbee, we are basically using here DSS, direct sequence spread spectrum technique here. Now, the most important concern here for the physical layer is the operating frequencies. Now we know that your Internet of Things here basically operates on the unlicensed bands, that is your ISM band here. So for Zigbee, your operational range of frequencies here is like 868 megahertz, 915 megahertz, and 2.4 gigahertz here. And it has 27 radio channels. Now, if I have here this as the first channel 0, which is your low power channel, then from channel 1 to your channel 10. So the data rate which is supported here is your 40 kbps. Now after that, I have channel 11 to 26. So it has 250 kbps of data rate, which is the maximum data rate here supported by your Zigbee. Now, this is here for your, these channels are for your 868 and 915 megahertz bandwidth, and these are here 11 to 26, 2.4 gigahertz. Another system specification is that it is using here BPSK as modulation technique, and it is using here as opposite quadrature phase shift kink. So this is the physical layer specifications for your Zigbee. It is here working under those frequencies which are used for your IoT, ISM band, low data rates, and the respective modulation techniques here. So this physical layer is actually specifying here the electrical, the transmission operating frequency specifications, which is the basic function for your physical layer here. Now after the physical layer, we have the data link layer. So we are using here the sub layer, data link layer here, which is your MAC layer, which is your media or medium access control layer. Now we're saying medium access control layer. So medium here, we know that we have the radio channel. So we can say that the airwaves here. So this layer here basically specifies that if there are multiple of these Zigbee instances, then how they will be accessing this shared channel. So this layer, the basic functionality of this layer is basically to specify the access mechanisms of this radio channel by the various Zigbee devices here. So it here implements CSMA C, which is your carrier sense multiple access technology with your collision avoidance. It is sometimes written as CD also, which is your collision detection. So this technology basically uses that you have to listen before you're sending the information. That means first of all, this is checked that isn't transmission is going or not. If not, only then the data is transmitted here. So that is basically checked here by checking the voltage here. So this is here implemented by a maglia, your CSMA mechanism here, and above that it here controls the transmission and scheduling of your data frames. This technology is enabled, so that means it is controlling here transmission and the scheduling of your data frames, and it also manages the time slots. So by these operations, we can say here that yes, this layer is responsible for controlling or that how the shared media is accessed here by the multiple Zigbee devices here in a network. So basically different type of frames are used here like beacon frame, which is used here by the coordinator. Then you have the data frames, which is used to forward your data. Acknowledgement of frames in order to read that yes, the data frame is successfully received. And then you have the MAC frame here for this MAC layer control here. So this is how Zigbee technology is enabled here for your Internet of Things. That means the various devices which will be used here under your IoT systems here. So if you specifically talk here about IoT and Zigbee, so that means Internet of Everything. Every device is connected to internet. So Zigbee enabled sensors, modules, and devices are here, enabling to communicate or providing as a gateway for various devices so that they can communicate here with some another cloud platforms or the wide area network. So this technology here is acting as a key uh, driver for your IoT systems here. So many manufacturers have shipped thousands billions of your Zigbee enabled sensor modules and devices for enabling this technology here. Now various corporations like your Atwell Corporation, Samsung, etc., they have launched many Zigbee enabled modules here. Green Peak has also launched some of the Zigbee enabled modules and sensor devices which will be used here in the smart home automation system here. So in this class of IoT enabling technologies today, we just have covered only one of the IoT enabling technologies, which is by itself referred as the Internet of Things, which is your Zigbee technology. So we will be studying about more IoT enabling technologies in our next session. So this is all here for today's session. Thank you so much.